So the problems that we're going to look at now have to do with the isosceles right triangles, or the 45, 45, 90. So number 7, I know that it is isosceles right because I have the two sides that are congruent. And I know it's kind of hard to tell, but the given side length is 6 times the square root of 2. And we have to figure out the length of the hypotenuse. So before we start, I'm going to write down my ratio of my angles. 45, 45, 90. Then now I'm going to write down the ratio of my sides. X, X, X times the square root of 2. And so the side that I know about is opposite of the 45-degree angle. So X times the square root of 2 is going to go there. And hey, what do you know? I really don't have to do a lot of work because now I know that X has a value of 6 times the square root of 2. And so now, to figure out what Y is, or the 90-degree angle, I'm going to take my 6 times the square root of 2, which is the value of X, and then I am going to times it by the square root of 2. And so, as we already know, anytime I multiply a radical by itself, it's basically undoing the radical. So this now becomes 6 times 2, which is 12. So my missing side length has a length of 12 units long. So now let's take a look at number 9. Number 9, again, it's given to me that I have 45 degrees here, so that means this one has to be 45. So it's a 45, 45, 90. Again, first thing I'm going to do is write down my ratio of my angles, followed by my ratio of my sides, X, X, X times the square root of 2. Then I'm going to fill in what I know. So my given side is 10 times the square root of 2. That is opposite of the 45-degree angle, so that's going to go here. And so that means that this side length also is going to be 10 times the square root of 2. So now we know what X is. And so since I know what X is, well, all I need to do now is times that by the square root of 2. Because remember, it's the length of the leg times the square root of 2. The length of the leg is 10 on the square root of 2. Times that by the square root of 2. Square root of 2 times the square root of 2 is 2. 10 times 2 is 20. So Y is 20 units long. So some take a little bit more work than others. It really does depend on the side length that is given to you. Okay, so let's jump down to number 13. So that's on the back. Number 13, it says it's given that a square has a diagonal length of 8. Find the length of each side. So for number 13, I am going to draw the picture. I'm a picture person. And I know that it has a diagonal with a length of 8. I know it's a square, so I know all my sides are congruent. So I need to find the length of each side. Well, because it's a square, you know all sides are congruent. So it has to be a 45, 45, 90. So I'm going to start by writing down my ratio of my angles, followed by my ratio of my sides. X, X, X times the square root of 2. So the 8 is the hypotenuse, or the longest side, or opposite of the 90. So the 8 is going to go with the X times the square root of 2. Now I need to set up an equation to figure out what is X. So x times the square root of 2 equals 8. To get x by itself, we're going to divide both sides by the square root of 2. And when you do these enough, you start to figure out patterns. So x is equal to 8 over the square root of 2, but we're not allowed to have a radical in the denominator. So we're going to multiply the top and the bottom by the square root of 2 over the square root of 2. And so I have 8 on the square root of 2 on top and 2 on the bottom. And 8 divided by 2 is 4. So hey, guess what? I know what x is now. X is 4 times the square root of 2. So a square has a diagonal length of 8. Find the length of each side. Each side is 4 times the square root of 2 units long. Now, the last problem that we're going to work in this category is number 18. So look at number 18. Notice how we have a fraction here. And anytime we have fractions, it always seems that it's going to be super hard. So let's break this one down. 45, 45, 90. So I'm going to start by writing down the ratio of my angles, followed by the ratio of my sides. X times the square root of 2. Now, what's really cool about this one is the 45 is the side that I know about, and it is 2/3 long, which means this one is also going to be 2/3. And the truth is, let me zoom out. Out of all of them that I've worked, this one's the easiest because it's x times the square root of 2, or 2/3 times the square root of 2. I don't have to rationalize the denominator. I don't have to do anything. I'm done. That is what my x is, or what my missing side length is in this case. 2/3 times the square root of 2. What you would think would be the hardest problem on here wound up actually being the easiest.